Hey everyone, I hope you all are safe and doing good. So in the previous lecture we have seen one dimensional arrays. Basically that was about introduction to arrays. So basically we have discussed 1D arrays. Okay. Now in this video we'll see multi-dimensional arrays, 2D array, 3D array, or you can add as many dimension as you want. But generally in programming or in use practically we basically use 1D array most of the time and sometimes 2D array. That's it. Not more than that dimension. So 1D array we have already discussed. Now in this lecture we will see 2D arrays basically, multi-dimensional arrays which are having more than one dimension. So here we have added one more dimension, that is we are discussing 2D arrays, two-dimensional arrays. Okay, now see, if I say like I've told you in the previous case we have taken one example. If in my class I have 60 students and I want to store marks of 60 students, what do you say? Obviously that we will not do that. We will declare 60 variables and marks 1, marks 2, marks 3, something like this. No, we just take an array and the size of array is 60. So we can simply write something like this, like maybe float or double, and name of the array is marks and here 60, something like this, right? Or second way in Java is, this is like C or C++ style declaration of array. Just the type, here the size, sorry, the subscript, this square brackets, and the name of the array, marks. This is just the declaration. Or is equal to, we can do something like that, like new, and we have like float, and here we can give size 60. But what if I want to store marks of 60 students in 5 subjects? Then marks of 60 students in 5 subjects. Then maybe you think that let's take 5 1D array in subject 1, subject 2, subject 3, subject 4, subject 5, and size is 60 for all the arrays. So we can declare 5 1D array. But suppose I want to store marks so in 10 subjects or 15 subject, so you have to declare 15 1D array. But that's definitely not a good idea. Okay. So is it possible that under one declaration, under one name only, we can store marks of 60 students in 5 subjects? Something like this. So like I have 60 students and I have marks in subject 1, subject 2, and 5 subjects. Here I am going to store marks, something like this. So it's like the data is in tabular form. It's in table. We have rows and we have columns. So we are having two dimension basically. One is this, one is this. Or you can say it's like a matrix. Matrix also something like this. Like if I, in mathematics you have heard about these things. Like if I write something like this, so this is what? A 3 into 3 matrix, nothing else. 3 into 3 matrix. Having columns, having rows. Right? So yeah, we know we have data. We need to store data. We have data in tabular form and we need to store that data in computer memory. So to store that kind of data, in a data which is in a table or data which is having two dimension, we use 2D arrays for storing this kind of data. So like this, in 5 subjects, suppose 60 students are there, so I'm storing the marks. So this is like 1D array. Like something like this, I can say float and this, and these are for subject 1, like this, subject 1, subject 2, subject 3, subject 4, subject 5. 5 arrays, 1D array we can declare. Okay, so for 5 subjects, this is not like that. We are having, this is the 1D array in that case, because for subject 1 this is 1D array, this is 2, this is third, this is 4, this is 5. Or if you declare something like this, then you have to take, like I'm taking array something like this, array of 1D array of size 5, so you have to take 60 1D arrays. Okay, that also we can do. So something like this we can do. This array will store for student 1 like marks in 5 subjects. This will store for student 2. So like this we can declare 60 arrays, 60 1D arrays, but that is definitely not a good idea. So we can declare a 2D array. So all these 1D, these are 1D arrays. And for that, we can add one more dimension in this, and that becomes 2D array. So it becomes 2D array is what? Basically, array of arrays. Okay. So the items in 2D array is what? Basically, arrays itself. Now, how you can declare this thing? You can simply add one more dimension in 2D array. This is 1D array. So just add one more square bracket. Just add one more dimension, one more size. Name of the array, any name you can take. Suppose I'm taking marks, the name of the array, any name you can take, is equal to new. And then same float. Here you need to give the row size. Here you need to give the column size. So maybe we can give like 60 and 5. 60 rows and 5 column. If you are visualizing this data in this table in this format, 60 rows, 5 subjects, 5 columns, or you can revert it like here we have 5 subjects and 60 students. So 5 row size and 60 uh, column size. That is also fine, right? But this is now you can say the declaration of 2D array. Simply the return data type, then something like this, two square brackets, the name of that array, the new keyword, then data type, and here first is what? The row size, number of rows. This would specify the column size, means number of columns in that 2D array. Okay. So 2D array, we can say it's a array of arrays. I hope you got this. Why I am saying array of arrays? Because here these individual kind of thing is what? Individual is like an array. It's a 1D array. So it is 2D array is what? Array of 1D arrays. Here all the 1D arrays are stored and that becomes like a 2D array. You got it? Now when we use like in game development also, when you have those grid like games like chess. So here to locate or to store that player position, you need 2 dimension. So these kind of games, to store data, to store this data in that is in tabular form, we use 2D arrays. Okay, in image processing also 2D arrays are being used, but mostly we use like 1D arrays. So here you can see 2D arrays are arrays of arrays. What you can say, 2D array is an array of 1D arrays forming a grid like structure with rows and columns. Okay, now they consist of elements organized in a rectangular format or tabular format, and we can access. We need obviously two index to access that element in a 2D array. Obviously, if a data is stored in 1D array, then we need only one index, right? But here we are having 2 dimension. One is row, one is column. So you have to specify in which row and in which column your data is. So you need two indices to access the element. So, and 2D arrays can also store primitive data like 1D array as well as object references. Like if you create, there is a class and you create object of that class, you can make 2D array of those objects. So 2D array can also store object references, strings and primitive types. We will show this thing. I'll show this thing practically. Uh, don't worry. So I guess 2D arrays are clear to you. This is one example how to declare and initialize a 2D array, but let's discuss this thing practically. How to declare a 2D array, how to initialize 2D array. Same, we have initialized 1D array in 3 ways. So same here, same concept is applied. Only we have added one more dimension. Same, in those 3 ways we can initialize a 2D array as well. Let me show you this thing practically. So in our this first project, let's create a new Java class here. And we are discussing 2D arrays. So 2D arrays intro, the name is this, and here in main, let's take a simple 2D array that is of type int. So this is how you declare, and the name of the array, any name you can take. Suppose I'm taking my array ARR matrix or ABC XYZ, anything you can take. So this is simply the declaration. No memory allocation till now. If you print here, if you want to print this my array, see now, variable my array might not have been initialized. There is no like we haven't allocated any memory. So it's just a reference. When you actually create that object, then only it would be referred by some address. It will contain some memory address, right? So right now, See, you will get an error. Variable my array might not have been initialized. And if you click here, initialize variable my array, if you click this, see now, this is like they have initialized it. Means initialize, it means basically in more specific, if I say, then this is what? Instantiation of this array. We have allocated now memory to this array. And now this my array has been initialized by the address. Okay. Practically, let me show you first those practically how these arrays are to be stored in memory. Then you will get this thing better. So now here we have declared, suppose this array int name is matrix and new 3 into 3, 3 number of columns and 3 number of rows. So how actually these are stored in memory? Not we can say that exactly like this only these are stored in memory, because we cannot directly deal with memory addresses in Java. These addresses are like abstracted away from programmers. We don't deal with these kind of things. In C and C++, we like directly deal with memory, but not in Java. JVM handle these kind of things. Okay. But actually, like I can tell you something like this, they are stored in memory. What is the main logic behind that? Like in heap area or stack area and something like this. But exactly we don't know what are the memory addresses and all. We just fetch the hash code value. Okay, that thing also I'll show you. In the previous example also we have seen. So something like this. This matrix is now a reference. So we have like two areas. One is heap. Suppose this is heap area and this like we have a stack area. Okay. So whenever you call main function, one stack frame for this main would be pushed in this stack. Okay. One separate stack area has been created for that. So one main frame, one frame for this main function has been pushed. So whatever the local variables and some other values are there, that would be stored here. Okay. And when you return, when the control will exit from this main, then everything whatever is there would be destroyed. Something like this will happen. Okay. Now let's see. Here we have, suppose like here we have a matrix. This. So new int 3 into 3. And this is what? Array of arrays. So here we have something like this. 3 rows and 3 columns. Okay. So 3 rows. So here we are having, for each row there is one array, separate array. So this is 1D array. These individuals are 1D arrays, 3 1D arrays. Okay. So now this is referring to this. And these 1D's array, these are again having 3 columns. Something like this is happening. Because we are having 3 columns and 3 rows. So 0, 1, 2 and 0, 1, 2. So like one row and this is second row, this is third row. Each row is having 3 columns. Right? So these 3 rows are these are the like 3 separate 1D arrays, and each is having like reference of the actual values here. That's why we are saying it is array of arrays. So whatever address of this will be stored in this matrix. Index is 0, 1 and 2. 0, 0, 1 and 2. Something like this. So basically this, how to access this element, you have to write the name of this 2D array, reference, matrix. Then first you will access this 1D array 0. I mean the row, in which row you are having, in which row 0. Now in which column? Now actual values are stored somewhere else and it is referring to that. The base address is here. So 0 and 0. This is how now you can access this element 0, 0. If you want to access this element, the middle one, what you write? The name, matrix. Then here we have 1. It is in the row which is having the index 1. And then again 1. The column index is again 1. So 1, 1. It will give you whatever the data here. So in memory, this is how actually the case is. So this is having reference, some address. Suppose any address of this 1000 or something like this. So this will contain 1000. Here also this will have some address. Suppose 8125. This element, the base address of this array is 8125. So this contains 8125. For this, suppose 2000. So it will contain 2000. So for this, suppose 3000. So it will contain 3000. So these are actually containing the, again, the references of the actual 1D arrays. Okay. So array and array. So it's like 2D arrays we are having. Fine. And now one more thing. These 1D, these arrays, the actual data, these are not stored in contiguous memory location in Java in 2D arrays. In C and C++, these are stored in contiguous memory location, either row wise or column wise. But in Java, it's not the case. It is not mandatory that these are stored in contiguous memory location. No. See, for these three elements, for this array, the memory address is started from here. For this three, in a separate, in that memory, some block would be allocated, and suppose the starting address is 2000. Yeah, the next element for this array is at 2004. So next is 2008, because the type is int and one element take 4 bytes. Yeah, these are contiguous within this array. But these things are, these arrays, separate rows are not contiguous. It's not like that. First in memory, first row would be stored, all the data. Then second row, then third row. No. In C and C++ it happens. But here it is not the case. Because in the diagram also, I think it's clear to you. Here we have these, this is 1D array for each row, memory address, and this array is somewhere else, this array somewhere else, and the third array is somewhere else. Okay, so basically we cannot like generally write down any formula to calculate the addresses, but conceptually if you write, then the same formula is there that is in C and C++, those we can use. But actually this is not the case. JVM handle these memory addresses internally, and JVM access the data based on indexes. First the row index, then the column index internally. These are abstracted away from us. We don't know the internal details. That's like beauty of Java. We don't have to deal with actually the memory address. We don't have to take care of that thing. Java automatically handle these things. JVM, the garbage collector, automatic memory management is there. So we don't need to take care about memory and all. Okay. So you don't need to go into that much detail. Okay. And even if we don't know, anyone don't know exactly what is happening. Like how JVM handle these things. But that is for sure. The data is not like, all the three arrays are not stored in contiguous memory locations like in C and C++. That is for sure. Yeah, within this array, whatever the data, it's 3 columns or 4 columns or 5 columns, that is stored in contiguous memory location. That is for sure. Right? Now let's see. I hope now to somewhat the memory representation or how actually the 2D array is stored in memory, that is clear to you. Okay. So if you simply write down this thing, if you do not write down this thing, simple int matrix. So this matrix is like not referring to anything because there is no actual array you have created or actual object you have created in the memory. So there is nothing, something like this. That's why it was showing that it is not initialized, the 2D array, the error. Okay. Now after creating this, after writing this line, after writing this complete line, if you will print now matrix, it will give you some hash code type thing, not exact memory address, but hash code regarding that memory address. I'll show you how you will get what you will get. Let me show you this thing. And see, if you initialize directly, you can initialize individual elements like in 1D array we have discussed. Directly you can assign the value. So matrix 0 0, I'll give 1. So where this 1 would be stored, 0 0 here. Here the 1 would be stored, 1. Next 0 1 2 2, then 0 3 3 here. Then 1 0. So 1 and 0. Here it would be stored, that is, here we have 4, then we have 5 1 1, and then we have 6. Here we have 6. Then we have 7 8 and 9. So for this row 7 8 and 9. Like this we can store like 1 2 3 4 5 6 and 7 8 9 in this tabular format. Row 0 1 2 and column 0 1 2. Something like this. So on the board you visualize this thing in this form, like in tabular form or grid form, but actually definitely in memory it's not in this form. Something like this is happening. in 2D array, how the data is to be represented, something like this only. So each individual row is at separate location. It's not like that this row, then this row, then this row. No, these are not contiguous. These are separate memory location. But yeah, this data is at contiguous memory location within this row. Okay. So for this row, like this, obviously this is the array having 3 rows or the memory addresses of the actual data, the references. So something like this is to be stored. Okay. Let me show you now this thing practically. So that was just declaration. Now we have initialized this my array. Means we have instantiated this array. New int row size. Suppose here we are having 2. Column size I am having 3. So in the matrix I am having 2 rows and 3 columns. Now if you print my array, then what do you think what you will get? Let's just select the current file and run this. It is printing some address. See, this and this, because it's 2D array, so 2 brackets are there. Then I means it is of type integer. Then at the rate some, it's not like that actual memory address. It's like some hash code related to that memory address. Okay. Okay. So in the previous case, when we were doing this thing, and when we were printing this my array, okay, then in this case this was might not have been initialized, so it was giving an error. Okay, fine. Now, if you think, let's just assign the values like my array, then sorry 0 at and 0 0. Let's store 8 here, and let's now print here not my array. Let's access the element that is 0 0. So at 0 0 we are having 8. Let's run this and see what you are getting. So it will print here 8. So like this you can assign all the values if you want. All the, how many values would be there? 2 into, how many elements should be there? 2 into 3, that is 6 elements would be there. So 0 1, then 0 0 1, then 0 2, then 1 0 1 1 and 1 2. Like this you can assign the values and you can print. There is one way. This is one way. Second way to initialize it, you can use array initializer rather than individual kind of thing. We can simply assign here only. But how you will assign? Suppose I'm having two rows and 3 columns. So first is this, or let's just don't put this. Here we are having, and within this, for individual row 1 2 3 bracket close. Then for second row, suppose 4 5 6 bracket close, and here we are having at last bracket close. So these are nested array. So within this array we are having 1D array. One is this, one is this. But why you are getting this error? See, because if you are using array initializer, you don't have to give the size. You can, means you have to leave it blank. It will automatically determine the size or the number of rows and number of columns based on the values. If you give the size like 2 and 3, it will give you error. Okay, so that is not allowed. So there is, this is the second way to initialize using array initializer, a 2D array in the same, at the same place. Third, the simplest one is this one. Let's just copy paste this thing, and let's just remove this 2 int. Comment out this, because if you do not comment out, then see the error. Variable my array is already defined in the scope. This, see, this we have already defined, and again we are defining, so it will give you error. Comment out this, and yet this is the simplest form. You don't have to use write in a new int and something like this if you are using this array initializer. So it will initialize the array 2 into 3. 2 rows, and each row is having 3 columns. Fine. Okay. Now if you access any element 0 0, so it will give you 1, because 0 0 we are having 1 only. So that's correct. And if you access here 0 2, let's run this. So if you access 0 2, then it will give you 3. because row number is 0, that is this one, and column is 2. So 0, 1, 2. Second index we have 3, so it will give you 3. You can do one thing, and other than that, you can do something like this. If you write here this, if you use this, then just delete this, and it at this point of time definitely you have to give the size, otherwise it will give you error. Okay, now here only, if you do not give, suppose let's just delete this, and we are just declaring, and after that in a separate line I'm initializing this using array initializer. So you have to use here new and int, and rather than this size we just initialize it. So in bracket will give you 1, 2 and 3, and for second row some values, something like this, and semicolon. So this is also allowed in 2 lines. You can do this thing. This also will give you 3. See the output. But one more thing I want to tell you, in Java it's not, I'm not writing this thing. Let's write down here only the size new int. You can give only number of rows. It's not mandatory to give both the dimension. The column size you can leave it blank. Yes, that's true. But row size you cannot leave blank. If you think that let's give the column size, let's leave the row size blank, this will give you error, right? But yeah, you have to specify row size, but column size is optional. You can leave it. And you can now see, we have specified that in this 2D array, we are having like row size is 3. So 3 rows would be there. Means 3 1D arrays would be there. In heap area, we have just done with that one array, 1, 2, 3. So 3, that array contains references to 3 1D arrays. So for individual array, how many columns are there, that you need to specify separately, because we haven't specified the column size here. So in that case, now if you simply write this, 0, 0 is equal to 8. And if you access now 0, 0, let's run this. It will not give you any error. Let's see. It will give you exception basically. Null pointer exception. First, you need to, you cannot store to int array because this is null. Now what is happening behind the scene? Let me show you. So this is the case. Now in heap, so we are having two, obviously we will be having 2 rows, means 2 arrays, 2 1D arrays we have. So like this 2. And in stack, for this, like in main frame has been pushed. So here we have name is my array for this block, and it is referring to here. Some address is there, suppose 1000. I don't know the address, so suppose 1000. Right? Now, here, these are references because this contains obviously the reference of some other array. So by default, if it's not there, anything, if you do not store anything, then it is null, we know. By default, object references are null. Because now we don't know how many columns, so how to create some other arrays and store the address. We have just declared that there are only 2 rows. So means 2 1D arrays are there within that 2D array. So one 1D array is this, one 1D array is this, not actual 1D array. These are storing the references of actual 1D arrays. Store would be created somewhere else, having some columns. And this will refer to this will refer to this. But right now, these are null because we haven't created this thing. That's why if you want to access, like obviously this is 0 and 1. So 0, 0. So that 0 is, I don't know where is that 0. We haven't initialized that thing. We haven't given memory to that thing. We haven't created that actual array. That's why it will give you null pointer exception. I hope you got this thing. So first, what you need to do, if you write down this kind of thing, you need to now create these 1D arrays separately. How you will do that thing? You will write something like this. Like I'm having the name of this is my array. So we'll write something like this, my array and 0. So my array is 0. This is the case. For this now you have to create like new, and we will have int, suppose 3. So for this, we are having int 3, means 3, a 1D array which is having like 3 columns or like 3 elements that would be created. New means created, and the address of that is now this is referring to this. Suppose address is 2000. So now at the place of null we are having here 2000. Now if you access 00, it will give you 0 because this is of type int. Int value would be stored here, and by default, the that default value of int is 0. So now it will give you 0 only. Like this only. Separately for this also you have to create. Right now here it is null, so it is not referring to anything. So for that also you have to create like my array, and this is 1. At this we are having 1D array, so you have to create like same new int and suppose 4. So it will create somewhere else 1, 2, 3, 4, and will this is the memory heap area. Obviously this is not outside of that heap area. So for 4 elements. Now suppose it is at 4000, so rather than null now I am having here 4000. So you need to do separately. You have to create separately these 2D arrays if you are using this kind of syntax. I hope you got this thing. And why you get, if you do not write this line, these 2 lines, then why you are getting those null pointer exception, that also I guess you got it. Now one thing you have noticed that here I'm having 3 rows, here I'm having, sorry, 3 columns, and here I'm having 4 columns. So array is something like this. There are 2 rows for this, 1, 2, 3. We are having only 3, and here we are having 1, 2, 3, 4. So it's like a special type of 2D array in Java that is known as jagged array. Or let me write down properly. These are jagged arrays in which each row can have different columns. Means it's an array with irregular rows. It's not compulsory that you have to take for each row same column. No, like in traditional 2D arrays. Different columns can be there for individual rows. And like this you can initialize. Here we have initialized, we have created 3 columns. For this row we have created 4 columns. So like this, as many arrays, 1D array you can create with a different column size. So these are known as jagged arrays. We will show practically this thing. Don't worry. Okay. Now let's get back to that practical kind of thing. So this will give you what? Null pointer exception. See, null pointer exception. Because right now in that my array is 0, we are having null, so we cannot access anything. To make this work, we will do one thing. You have to create like my array, and for 0th row for that array separate, you have to create now actual object of that array, new int, and size I'm giving 3, and for second one I'm giving the size 4. Here I'm giving 4 size. Fine. Now you can initialize like 0, 0, 8, and now you can access this. It will give you 8. Now it will work. See, you are getting now 8. Fine. And now if you initialize something like this, or if you want to access 0, 0 or 0, 1, what do you think? What you will get? Pause the video and think about this. My array 0, 1. You can just visualize this or draw that thing up piece of paper, and you can visualize what you will get here. See, it will give you 0 because by default int, the default type or the default data for this int is what? 0. So we haven't initialized anything, so it will give you 0. If you access 0, 4, what do you think? What it will give you? See, array index is out of bound because obviously for 0th row, how many columns are there? 3. So index can go from 0, 1, 2. That's it. It's not go from beyond 2. 3 also will give you error. Index is out of bound. Till 2 you can access. It will give you 0. And if you assign here something like my array is 0 and 3, I want to assign some value. See now error. Array index is out of bound. because 03 is not valid. We can write down up to 012. Yes, so 0 or 1 or 2. So it will give you error index out of bound. So this also you need to take care. Index out of bound errors kind of thing. Okay. And you can modify the value also. Suppose let's just comment out this thing. And I have created this array, my array, and I've initialized this array something like this. Now I want to change the value. This 2 or this 5, I want to change to 15. So it should be 1, 2, 3, 4, 15, and 6. Pause the video and try this out. What you should write here that this value would becomes 15. So first, I hope you have done this. First, let's think how to access this element. So it is in one row, first row, the index is first. So it should be like first. And the column index is 0, 1, 2. It's 1. So 1 and 1. Should become 15. Should become 15. So if you access this now, 1 and 15. Sorry, 1 and 1. So it should give you 15 rather than 5 because we have modified this value. See, it will give you 15. Fine. So like this, you can modify also the values of 2D array, something like this. How to access that also I have told you. First is the row index, second is the column index. Array name, row index, column index. Okay, so you have to like, if you want to access anything, then it involves dereferencing of two pointers, one for row, one for column in 2D array. Okay, and basically I told you like memory addresses, we cannot calculate the memory address using some formula that we have done in previous case in 1D array, like base address plus we have done that index you have given into size. This kind of formula is not allowed in 2D array because in Java 2D arrays are basically array of arrays. These are not stored in like contiguous memory location row wise or column wise that like in C and C++. So we cannot directly apply any formula to calculate the address, but if you want to calculate conceptually, you can just apply the same formula that is in C and C++. Now one more way I just want to show you to initialize arrays at runtime using scanner. We will not discuss first the jagged arrays. Let's discuss the traditional 2D arrays first, then we will come to the jagged arrays. So now let's have an array something like this, int this, and rather than initializing at here, we are just having declaring the size. Int the size is 2 and here we have 3. Simple. And I want to take arrays, sorry, the input, I want to initialize this array at runtime. Fine. How you will do that thing? Obviously, we are having rows and columns. So you need two loops. One to handle number of rows, one to handle the rows and one to handle the columns. That we have seen in pattern printing questions. Okay. So the data is in tabular form. So if there are two dimensions, so you need obviously two loops. So how to take input from user? Let's create a scanner object. So first loop will handle the number of rows. How many rows are there? Then the inner loop handle the, we have discussed this thing in pattern bending question also, that the columns, number of columns. So number of rows are, how many rows are there? 2. Right? So for int I is equal to 0 and I less than, either you can simply write 2 or if you don't want to write down this 2. So one thing we can do, we can just find out the length. So let me show you that thing first. If I write something like this here, let us comment out now first. This is the thing. Array we have declared and we have initialized. So if you print here, this my array dot length. What do you think what it will print? On my array, I'm calling this length field. So length of my array is what? Obviously it will give you how many rows are there? 1 and 2. Because to separate, there is in heap area. For that, this my array is referring and there it is having only for 2 rows, only two 1D arrays it will create an array 1 and 2. So the length it will give you 2 definitely. See, the length is 2. But if you print here like my array 0 dot length, it will give you what? Let's run this. It should give you 3. Why 2 and 3? Let me show you. See, if this is the case, 2 and 3 I'm having on my array. I'm not having this thing. Only this thing I have. So on this, if you want to print my array dot length, I'm just writing this my array and whatever the length field. So length of this my array. This is my array. This is referring to here. So length of this is how many, like length is what? How many data or these boxes are there? The array, how many elements are there? 1 and 2. Definitely number of rows are there. So it will give you 2. But if you call this length on like my array 0 dot length, my array at index 0, I'm having this. So reference, so it is referring to here. Actual object is this. So the length is how many data can store here. The boxes are there 1, 2, 3. So means basically it will give you the number of columns in each row. So it will give you 3, 2 and 3. You got it now? If you apply length field on directly my array, what it should print and why it is printing 2. If you apply at my array, if you print here why my array 1, index is 1 and then length, then what it will give? Pause the video and you can think. So at 1, it is referring to this is the actual array and the length is what? 1, 2, 3, 4. It can have 4 elements, so it will give you now 4. Rather than 3, it will give you 4. I hope you got this. Okay. So it is 2, it is 4 in this case. Fine. Now we were initializing the array at runtime. Okay. So this we can represent something like this. So in tabular form, if you represent this, then it would be like something like this 0, 1, 0, 1, 2. Something like this. You can access this 0, 0, 0, 1, 0, 2, something like this. Right? So I want to take input from user. So one loop will handle number of lines or number of rows. Second loop will handle number of columns. The outer loop, I have told you, always handle the number of lines, number of rows. So outer loop should go till 0 to 2. 0, 1. Not 2, 0 to 1 we can say like 0 and 1. Outer loop should be like 0 to 0 to less than 2. 0, 1. Or how you can find out this? This is what number of rows. How you will find out? Just write down my array dot length. I less than my array dot length. Simple. Right? So outer loop we can write like I is equal to 0 and I less than my array dot length and I plus plus. As simple as that. Because this will always give you number of rows. Now, number of columns. 1, 2, 3. How to find out the length or the number of columns? How many columns can be there? Simple. Let's take one more for loop. J is equal to 0 till j less than my array, whatever the I, whatever the row. I means at first I is 0. So here it would be 0 means this row. Next time I becomes 1. So it would be 1. So means this row. Whatever the row, dot length. It will give you number of columns in that length and that much data we want. We want that inner loop should iterate till that much time and j plus plus. And here simply using scanner we can just take the value. Simple. Right? Like my array. Have to write down my array and I and j is equal to scanner object dot next int and something like this. But I hope this condition is clear to you. These two loops. And same when you print, then you have to apply same loop. Okay. Let's run this program. So it is now, let's just comment out this thing. I just want to show you the functionality of length only and uncomment this. So I should be less than 2, or directly we can write down here. Oh, sorry. So here rather than 2, we can simply write whatever my array dot length and I plus plus. Outer loop will handle number of rows, and now it's turn for inner loop. It will handle number of columns in each row. J less than my array, whatever the row number, it would depend on I dot length and J plus plus. Why I'm not writing here 2 and 3? Because the Java support 2D, jagged arrays. So something like this. For each row, maybe number of columns are different. So we cannot specify here like 3 or 4 or something like this. That's why for each row, it will automatically find out the length, whether it's 3 columns or 4 or 5 or 2 or 1 or whatever. And till that value, this loop would be iterated. So now we simply take input from user in my array, whatever the I, and then j. Row index and column index is equal to scanner object and next end. As simple as that. Right? Now same. Now we have taken input from user. Now you have to print. So for print also you have to apply same loop. So let's just copy paste the same for loop, this and this. And rather than now taking input, you have to just here print the values. So SOUT, and if you simply print like my array, whatever the I value and then whatever the j value. This thing I want to print. Not okay. I'll just decorate this a little bit, but first let me show you output something like this. So I hope you got this. This is how, like, at runtime we are going to initialize an array and we are just printing the array. So we are printing the array with this loop. Okay, let's run this. I'll dry run this also, don't worry. So let's just take input from the user 1, 2, 3, 4, 5, 6. And it is simply printing 1, 2, 3, 4, 5, 6 because it will take only 6 elements. 2 rows, 3 columns, 6 elements. So it is taking 6 element and it is printing 6 elements. But I don't want to print something like this. I want to print in a like tabular form. In first row, I'm having 1, 2, 3, then 4, 5, 6, something like this. So this thing you need to decorate a little bit. I hope you can do that. Is not that much tough because we have done many pattern printing question. So just print here, and after printing one element, just add one space. And after each row, after printing like each row, just go for a new line. That's it within this for loop. This thing we have done many times in pattern printing questions. So let's enter 1, 2, 3, 4, 5, 6. See, in first row 1, 2, 3, then 4, 56, and 6. Okay, this is how. And you can simply write here something like this also before taking input. Enter elements of 1D array. And here also, I want that it should print something like this. Before taking input, let's print something and it should print like element and this bracket, then 0, 0. So 0 means I value we will print first. So plus whatever the I value, let's fetch that thing. Then plus, then this closing bracket, and then again opening bracket, and then plus whatever the j value, that is j value would be at first 0 and both 0, and then plus, then closing bracket, and something like this I want to print. Okay, let's run this and see what output you will get here. I don't know. It will, yeah, it is working exactly what we want. Enter elements of array, element 0, 0, 1, 0, 1, 2, then 3, then 4, then it's 5, then 6. That's it. and it is printing 1, 2, 3, 4, 5, 6. So like this you can decorate a little bit, but that's not like that logic that you have to think, but it's like just decoration kind of thing that is not that much stuff, I guess. Just you have to do simple in system.out.println and something. Okay, now you can try run this program and you can see. Let me just try run this for you first. So this is how we are taking input from user. Okay, now for this, like, 2 rows should be there and 3 columns should be there. The memory has been allocated, right? So 0, 1, 0, 1, 2. In memory, actually, I have told you how memory would be allocated, like in heap and stack. So you can just draw something like that also. Now, int I, we have first, there is I, that is 0. Now, the condition is my array dot length, it will give you 2, we know, because the number of rows are 2. So condition true, yes. Enter here. Now j, now we have j, that is 0. It would give till, it would run till my array I dot length. I is 0. So my array 0 dot length is what? 3 only, because number of columns are 3 only in both the rows. So condition true, it is 3. Enter here. Now my array I is 0, j is 0. So at this place, whatever you will enter, that would be stored. Suppose I have entered 1, so that would be stored here. Okay. Now j plus plus, we are still in inner loop. So j becomes now 1. Is this condition true? Yes. Again enter here. Now this is 0, this is 1 at this place. Some whatever you enter, that would be stored. J plus plus, j becomes 2. Condition still true. Enter here. Now here whatever you enter, that would be stored. Now j plus plus, j becomes 3. Now this condition is not true. So we'll exit from this inner loop and now we are on this outer loop, that is I plus plus. Now I becomes 1. Condition true. 1 less than 2. Yes. Enter again. Now again j would be started from 0. J would be initialized 0. So again now this j is 0. So for same 0, 1, 2. For the second row, same iteration of j would be there, like 0, 1, 2, 3 iteration, and the value would be stored here. This is how it is happening. Same for printing also, it's not that much tough. The loop would be same. Everything is same. Just you are printing here I and j value. So whatever I or j is 0, 0, it will fetch that value. JVM will fetch that value and will give you. Right? For same, for 0th row, this inner loop would be iterated 3 times. So we are able to fetch these 3 values. Then you have just added a slash n. So the control will be the next line and the 3 values would be there with a space. So I think that is not that much stuff. You can dry run yourself, whatever that printing logic. So when we are printing those elements with these 2 loops, you can dry run that thing. That is not that much stuff. Okay. Now let's take example of jagged arrays. I've told you what are jagged arrays. These are basically arrays with irregular rows. So we can say like a jagged array is an array of arrays where the rows can have different number of columns. The rows can have different number of columns and you can specify how many, we can only specify like how many columns can be there. So here, let's just comment out this thing and let's discuss the same thing with the jagged arrays. So I'm taking here, let's just uncomment this thing now. So this is our jagged array. In jagged array, you can specify, you need to specify only the row size. You can leave this column size empty because we are going to specify for each row how many columns we want. So you have to leave it blank for a jagged array. Now for 0th row, I want 3 columns. For first row, I want 4 columns. So individually, we are having different, in each row is having different columns. Okay. So same for jagged array. Now, if you initialize this with the help of at runtime, if you want to initialize it, then same loop you have to give, or at here only also you can initialize it. Don't worry, without runtime also. Now with array initializer we can initialize here also. So for the first row, just write down how many columns I want, like values 1, 2, 3, 3. But one thing you need to take care, if you are using arrow initializer here, so you have to remove the size. Automatically the size would be determined by the values you give. So three values are there, so here it would be 3. So rather than 4, you can simply initialize it with array initializer like 1, 2, 3, 4. Something like this. So the row 1 would be 3 having 3 columns, row 2 would be having 4 columns. This is how you can initialize. One way is this. Or second way is here also, like just remove the size and here only you can give the initializer. So within this, for the first row, I just want 2 columns. For next, suppose I want 4 columns. So that is also jagged array. There would be 3 rows and there would be, for each row, there would be different columns. So this is also another way to initialize a jagged array. So these are basically going to save the memory space when you want to store the data that is irregular. So a jagged array basically allocates memory only for the required number of columns in each row. Only for required number of columns in each row. It's not like that if there is maximum 4 rows, so you have to create 4 into 4 matrix. For each row there would be 4 columns. No, in first row I want only 2 data, 2 values. In second row I want only 3 data. So use jagged arrays. It would be going to space, it would like space the save the space, memory space. So when you are dealing with irregular data, then these are useful. But the indexing should be very careful because the row size is different. So the indexing, if you want to access the jagged array element, so indexing, when you do that, that time you have to be very careful, right? At runtime also we can initialize. So let's just delete this thing. And here we just give the number of rows only. And at runtime now I want to initialize this. So same loop you need to apply. Let's just copy paste the same thing because obviously you need 2 loops. Scanner object, enter number of elements, enter number of elements of my array. It should be till length and it should be till my array for each row dot length. So in this case, it will run if you specify here the values like it's 2 or it's 3, it will run because the values are fixed. For each row, there are 3 columns, but in jagged array, the number of columns are not fixed. So, especially in jagged array, you have to write this thing. For each row, calculate the length explicitly. Now enter elements and then just simply print. So let's run this and see. But for that, first you need to okay, let's run this. It will give you error. Illegal start of expression in line number 19, 1943. Okay, first just remove this. And let's run this now. See, null pointer exception. Cannot read the array length. Cannot read the array length because my array I is null. Because it's null, my array is null because it's like there are 2 rows, but this is blank. So number of columns are not there. So that has not been created, those arrays. So it is having those my array dot this bracket 0 and my array 1 is having null only. They're not referring to the actual object. You haven't created anything. If you are using this kind of syntax of jagged array, you have to explicitly use, I have told you, my array and sorry, my array is equal to, you have to create explicitly int, sorry, here you have to note my array, it's 0. My array 0, it should be 3, but 0 through having 3 columns, and same my array 1, this will have 4, 3 and 4, right? Now it will work. Let's run this and see. So first 0 0 element 1, then 0 1, then 0 2, then 1 0, because in first I am having only 3 columns. Now it's a second row, that is index is 1 only. So like 4 5 6 7. See now, first is having only 3 columns, and second row is having 4 columns. So this is what jagged array. This is how you can initialize a jagged array, right? Okay, so we have discussed int type of 2D array. You can create any 2D array, any primitive type, int, float, double, boolean, char, or those arrays you can create. You can try out these things yourself. Rather than int, you create all the primitive types of 2D array. Try to create and store the value and print those arrays. Now, rather than primitive types, 2D array can store object references as well. Like 1D array can store any arrays or strings or any object of any class, something like this. Same 2D array can do. Let's discuss this thing with practical. I am having a class, same employee, having two attributes like name and emp id. So let's create, if you create object of this class, we know simply have to write down employee, the name of the class, then the object is equal to new and employee and the default constructor, right? But here I want to create 2D array. In 2D array, I want to store object references of employee. Okay, so 2D array means the type, we write something like int and these two brackets. So here we don't have int, the type is our class name. This is user defined type, basically we can say. So the type is employee, this. And now the name of 2D array. Suppose I'm taking employees, more than one employee would be there. Now new, and then the type again, employee, and then the size. So like 2 and 3, something like this I want to give. So it's 2D array of objects of type employee, right? So now how actually in memory it is going to be stored? Like here we have like some heap area, and in stack, like in mainframe, this is I'm having suppose employees. So this will contain new employee. It's like 2 and 3. So 2 rows would be there and 3 array of arrays. So this will have 2 like 0 and 1. These are 2 arrays which will have further 1D array, 3 1D arrays. It's a 2D array of 3 1D arrays are there. Okay. So row 2 and there are 3 1D arrays. Something like this. 1, 2, 3 having 3 columns. So it will have like this. Sorry, not 3 1D array. We are having only 2 1D arrays having 3 columns. Having 3 columns. Columns are 3, so 2 1D array. These are references to these 1D arrays and having 3 columns. Something like this is happening here. Okay. But now the thing is, so 0 and 0 if you want to access. So it's not like we are storing here primitive type. It is object reference. So these arrays, these 3, these are itself containing some addresses. Actual object you have to create. Like for 0 0, actual object you have to create. This will also contain some references. Some references. Because these are object references. These are not primitive type. If there is primitive type of type int, we can directly store here integer value and that's it. No. But these are not primitive type. We are storing here object references. So you have to create an object which will have like name and emp id somewhere else, the data, name and emp id, and this is referring to this. Again, name and emp id, this is referring to this. Again, name and emp id, this is referring to this. Something like this. So this array is not containing the actual data, actual object, but it is containing a reference to the actual object. And this funda we have already seen how this is happening in the previous videos. Okay, these are not biggest primitive types. Okay, so now you have to simply, if you write this thing and if you want to access 0 0, it will give you some exception or error kind of thing. You have to create object first. You have to create, like here we have employees, the name is then 0 and the access 0 is equal to, now create object new and employee. Now actual object would be created when this line would be executed, and now at 0 0 means 0 and then 0, at this place it would refer to this. Now you can access. How you can access? You can write like employees 0 0 dot. Now dot means here some value has been allocated in heap area which is having address for this name and emp id, and value would be stored. Suppose you have entered some value. So dot name, it will give you name. So here also you can store like Jenny. Something like this you need to take care. Okay, if you want to create an 2D array of object references of any like class type, right? So in heap area, how this is basically represented, to somewhat it is clear to you. Till now, it is same. Till now, if you do not create this kind of thing here, like this is suppose heap area. So till now, I think it is clear to you. We have discussed this thing. 2, 3. So it will be an array having two. This is referring to two 1D arrays each having 3 columns. That is simple because it is array of arrays. So array of arrays. Fine. Individual item is like a 1D array, 1D array. So it is storing address of 1D array, address of 1D array, having 3 columns. Now, but here in the previous case, we were storing directly values here. You can, after this, you can directly assign the value, but here you cannot directly assign the value something like this because we cannot directly store value here. These are object references, right? So these itself will contain references of actual object. Actual values of the name and employee ID would be somewhere else, and these are referring to them. These are class objects because, right? So you have to create the actual object to store for this location. So employee 0 and 0. This is 0th index. For this location, you have to create actual object, and how to create a class object we know new, and this the class name, and this is basically default constructor. So this is now creating the actual object, and now it is referring to this, and now you can access dot name is equal to Jenny. So Jenny would be stored here somewhere else. Something like this is happening. So for each 1 2 3 1 2 3 6 times you have to write down this line. For 0 1 also, for 0 2 also, for 1 0 1 1 and 1 2 also, you have to create object, you have to write down this line, and then you can access, you can store the value and you can access. I hope you got this thing. This is not that much confusing. If you if you are confused, you can just take a break, pause the video, and just again watch this. So let's just do practical of this thing. So let's just comment out everything here, and suppose if you want to create another class, employee, and this class is having like string emp name and two things only, int emp id. That's it. Or let's take one more here method, that is display. So in this method, we are just displaying the emp name and emp id, whatever you will take, you will input. You will take input, right? So for this class, in the main, so this is our main. Here only, let's just create here. Within this main, we are just creating a 2D array. So let's just write here employee. So 2D array we are creating, and the name I'm taking employees is equal to new and employee 2 and 3. Jagged array is also possible of this type that you can try out, but I'm just taking the traditional 2D array, not jagged array. Two array and two row, and every row is having 3 columns. Now, if you think, let's just do employees 0 and 0 dot emp name is equal to Jenny, and let's just print the same thing. Employees 00 dot name, emp name. Let's run this and see what output we will get in this case. See now, null pointer exception. Null pointer exception. Cannot assign field emp name because this employee 00. See, employee 00 is null, right? Is null at this. because you haven't actually created any object. I told you, you have to write down this line first. So employees, you have to create first the actual object 00 is equal to, now create object new, have to create object new and the class name, sorry, the default constructor. Now that's fine. Now you have created the actual object and that this 00 is referring to that actual object. Now you can access this kind of thing. So after that, after this line, you can write down this emp name is equal to Jenny. I mean, you can assign this thing and you can print, and it will print the value. It will print the name Jenny. See, it will not give any error at this time. No exception is there. Fine. And same if you want to do like 000 dot, sorry, 00 dot emp id, and let's just make it 101. Same you can access. So rather than accessing, you can simply call this method display info. So you can just call this method employees on 00 I want to call dot display info. So let's run this and it will show the name and emp id. Suppose if we want to call this method on employees, simple. So see, it will give you error. Cannot resolve method display info in employee, because employees, it's not an object. Basically, yeah, it's an object reference of those 2D array. Employees contains address of that array within that heap area, first array having two rows, having two those boxes, and then those three arrays. So you cannot access display info. You have to deep time. You have to go till employee 00 till that index, and then you can access display info, right? So if you display this 0 also, that will also give error, because at 0th index also employee 0 also will not give you display info, will not give you access to this method. Only this will give you access to this display info method. This thing you can go to the program and you can see, right? So now it will print Jenny and this. Like this, you can initialize all the employees, like the objects, and you can just print, or using what you can say that at runtime also you can do this thing with the help of for loop, right? So that thing you try out. Or rather than this, you can take a jagged array of this also, object references also. Fine. So if I run at this point of time, let's see what output or what error kind of thing you will get here. Null pointer exception, because now we haven't specified, like only two rows are there, but like how many columns in each 1D array, we haven't specified that thing. So that you have to specify. So for that, what you can do, employees 0 is equal to new, and employee, how many columns I want? 3. Sorry, here I want 3. Suppose 3. So now 00 would be maybe name, or 0 we have emp id, and let's now run this and see. Now it will print both these Jenny and 101, because we have for the first row there would be 3 columns, right? And before also there we were having 3, but now individual kind of we want. And for employee 1 we want, suppose here 4, that is also fine, or 2 or 5, or any different type of columns you can assign here, and these line would be same. Okay, so 00, then 01. For 01 you have to write down the same line, for 02 you have to write down the same line, and then you can just assign these values, different values. If you access here for 01 display info, what do you think what you will get? Let's run this. 01 is still null pointer exception. See, cannot invoke this display info because 01 is null still, because you have initialized only 00. You have created actual object for 00 only, and you are accessing 01. So if you want to access, then the same line you have to repeat for 0 1. Now you have created the actual object using this line for 0 1 also, and now you can access this, but you haven't initialized these two things. So what this will print display info, null and 0. For string it's null by default value. For emp id it's integer, it's 0. So null and 0 it will print. Okay, I hope you got this thing now. Have to create 2D arrays of object references. So let's discuss now 2D array with for each loop. First, let's just see this thing and pause the video and think, well, this is this correct, or will it give any error? I'm creating a 2D array, my array, new int and 2 and 3, 2 rows and 3 columns, and then I'm just initializing 0 is equal to AB and my array 1 is equal to CDE. So what do you think? It will give error or not? See, it is of type int and we are storing char type, but it will not give any error because internally char is also stored as unsigned int, we know. So A would be stored as like 65 because capital A in ASCII is 65, it is 66, something like this. It will not give any error. Now I want to print the values of this with for each loop. I don't want to use that traditional loop because for each is simpler to use. So first for, and what for each loop will do, if suppose I was having array numbers and which was having like 1 2 3 4, and when you are writing 4 like int num and number, something like this, right? So I have told you that this num will represent the actual element of this number. So the first element of this array would be first assigned to this num, and then we can simply print num, something like this. So same will be happened here, right? But now it is 2D array. So there would be two loops in 2D for 2D array to print elements of 2D array. So first loop will have individual rows from this my array. Like this is the memory and here it will have like two. This is my array in stack, in this stack and referring to this. So this is what individual 1D array, 1D array. So the outer loop will fetch this 1D array and it will store in some 1D array. So outer for loop, for this you have to take here 1D array. You cannot simply take a element or simple a variable because this is 1D array. First it will fetch this 1D array and it will obviously to store this you need 1D array. So 1D array and any name you can take like ARR, then colon and then the name my array. Simple. Now this inner for loop. Now within this 1D array we are having like this 1 2 3 1 2 3. Three columns are there. So it is referring to this, it is referring to this. Now you have to access individual elements within this row. So now the inner loop will have a simple element, suppose num, and from this 1D array. In ARR now we have fetched this first row. So from ARR, now from ARR from the first row we take the individual elements and we store that in num. I mean the for each loop will store in this num. And now you can simply print whatever the num is. Simple. It's not that much tough. I hope now this is clear to you why I'm taking here this 1D array and here I'm taking simple element. Because I have told you here, whatever you take here, that variable actually store the element of this collection. So in this case, this is a simple array. In simple array, I'm having elements, so it will simply take a variable. But here, this my array is a 2D array, array of arrays. So this my array basically contains what? Reference to this array, and this array containing 1D array individually. This is referring to this 1D array, 1D array. So this block is individually 1D array, 1D array. So first you are fetching this, then you are fetching this. So to store this 1D array, I mean, not 1D array, that address basically, the reference. You need a 1D array. So that's why we are taking here 1D array ARR. From this reference, now we are fetching individual elements. So that's why in inner loop we are taking a single element that will fetch from this ARR. Next time, this this is also 1D array that would be fetched and stored in this 1D array, and then individual elements of this would be in num, and we can just simply print. Simple. You can decorate it a little bit to print in the tabular form that we have done. Okay. Let me show you practically this thing. So like this, we can use for each loop with 2D array as well. Let's just comment out everything, and in main we simply take now a 2D array, nothing else. So let's take this only, or let's take a new array. So we're taking a jagged array. So my array 2 is equal to, let's initialize this using the initializer list only, and we just take characters. Same for the second row, we are having here index is 1, and here we are initializing this with the, suppose d 3 columns are there. So jagged array we have taken. Now let's traverse this with for each loop. So outer for each loop will first having an array like ARR and whatever the my array. Then the inner loop will fetch the individual elements, that is int, suppose element or num, anything you can take, and from ARR. Now we can simply print here the value. So if you want to print in a matrix form, so just remove this ln and just print here whatever the element is, then with a space, and after inner loop just a new line. Simple. Let's run this and see. See, now it will print not ABCD, but obviously it is int, right? We are printing here int element. So the ABCD would be converted into the ASCII value that is of int type, that is 65, 66, and something like this, right? Suppose if you think, let's take ma'am here char, and now print element char. So provided is char, but required type is int. It's not char. Like here also we are taking arrays of int type. So if you take here char my array, but here provided is char this and required is int, because this is of int type. If I take here char, and here also I am taking here char, but now it will give you error. Here you have to change everywhere char and char. Let's run this, and this time it will print ABCD. See, right? So like this, you can use for each loop also to traverse 2D array, 1D array as well as 2D array. Now you would try out different examples, traversing like printing a 2D array, different type of array, int, double float, or something like this, and with traditional with for each loop. Try out this thing. So we have done this 2D array. Why we need 2D array? Because it is efficient data organization. It gives you. It allows like the data is in tabular form or grid form, so it's more intuitive for you how to store data, okay, when you use 2D array. Matrix operation, if you want to perform, there are some metrics like addition, multiplication, or transpose of a matrix. So those things we'll do with 2D arrays. In games development also 2D arrays are used. That thing I have told you, in those games which are grid based games. Okay. Declaration, and how to declare this array, how to initialize, everything we have discussed with example. With loop also, with direct initialization also. Loop means at runtime, how to initialize 2D array. And this is what direct initialization with array initializer. How to access 2D arrays, you have to use two indices, row index and column index. Then you have to take care of the bound checking also, and most languages use the row major order for element access. Basically, row major, column major are in C and C++, because the elements are stored in contiguous memory locations. But in Java, it's not fixed. I told you how elements are stored in 2D array. JVM handle everything. Okay. So this is how you can access 2D array. Just one example they have given. And 2D arrays memory location. This thing also I have discussed with you with proper diagram. Right. So that thing we have done. How to initialize 2D array at runtime. This thing I have told you at runtime with user input. You can take, yeah, you can take input from user also, like how many rows you want, how many columns you want, like m and n. So rather than writing fix in those square brackets the value like 2 and 3, you can simply write down the variable name also. That is also fine. Suppose if you enter user, if you ask user to enter how many rows you want, and that I store in m, how many columns in n. So rather than writing 2 and 3, here you can simply write whenever you specify the size m n. That will also work fine when you declare this array. Obviously, you have to write down the complete syntax, right? So that is also allowed. Now, create the array with, okay, these are the specified dimensions. So you can create the array with this and you can populate the array with loops. That is simply but nothing but runtime initialization with loops have to take input with scanner object. This thing we have seen. Runtime initialization, this thing we have seen with scanner object, right? With for each loop also I've told you how to access this with for each loop, right? Outer loop, inner loop, and this is more simplified syntax. So you can prefer the syntax if you simply want to traverse 2D array. This is one example of for each loop. The outer loop is having, this is what the array, and this is what the individual element we are accessing. Two loops are there. Advantages or what? Yeah, if you represent the tabular data, then it is the most, you know, efficient type of organization or efficient representation of the data. With the 2D array, we can do this thing. Like it's a compact representation of tabular data in memory. Fast access, directly you can access any element with the index. That is in 1D array is also possible. Direct access or random access. So it will take constant time, order of one time only, right? Matrix operation, if you want to perform matrix operation, that would be easily done with help of 2D array. Okay. Now, drawbacks is what? Fixed size. That same 1D array. The size is fixed. So in this case, also the size is fixed. Size cannot be changed after initialization in most languages. Okay. Memory based. When you there are sparse metrics like less data you want to store, then most of the elements would be empty. So in that case, it's not good idea. But yeah, in that case, we can use jagged array. Okay. Now, application like game development or image processing or data analysis, these are some applications of 2D array, like storing for individual pixel of this image. There is 2 dimensions, so 2D array we can use. Okay. Now these are some coding exercises for you. You can take two metrics and you can add two metrics, those metrics, and you can print the sum of these metrics. Or you can take one matrix and you can just print the transpose of that matrix. These are two simple exercises for you to do. Okay. Now that's it. In the next video, don't worry, we'll see some exercise on 2D array also, 5 or 6 exercises. But for now, you can just try out these two exercises. Addition of two matrix and transpose of a matrix. Fine. So that's it about 2D arrays. Basically, most of the time 1D arrays are used. But yeah, sometimes 2D arrays are also used. Okay. But less than 1D arrays. But you should familiar about these arrays. Now, if you want to create more like 3D array, so you can simply add one more dimension. Int 3 square bracket and 3 dimension you can take. But that rarely we use. So we'll not go into that much deep. We just discuss 1D array and 2D array. So in the next lecture, we'll see some exercises on 2D array. Fine. So now I'll see you in the next lecture. Till then, bye bye. Take care.